Okay, my mic's working, it is. So what I'm going to do today is secretomes. Everybody talks about exosomes, but actually what you should be looking at as well is secretomes. Secretomes have more function, they're easier to make, they're more stable, you can freeze dry them, and I'm going to look at chemical signaling. You cannot understand regenerative medicine unless you understand what it's doing. And one of the big problems that I find with doctors, and everybody knows the products, but they don't really know the physiology very well. And this is always the cross between scientists and doctors. Doctors don't know enough about science, and scientists don't know enough about doctors. And we have salespeople in between that try and bridge the gap. And when we have a problem, they don't. So if we consider the human organism, so the human organism is the conductor. The baton in his hand is the secretomes and the violin is the exosomes. So if we consider that for a moment, the conductor is standing in front of the stage. He's looking at violins, woodwind section, all the different things. And what he does when he moves his baton is secretomes. So secretomes is everything. But the violin that's playing on its own, that's exosomes. So exosomes are very specific, going to do one thing, and that is it. Secretomes, so they're a collection of all the different things. The interleukins, cytokines, exosomes themselves are obviously contained within secretomes, and exosomes and secretomes have the one big advantage that because they've no cells, they're biologically active, so as a consequence, you can transplant and you don't have an immune thing. This lecture is skewed a little bit towards secretomes. I use exosomes as well, but that's because I was at Cambridge University a few weeks ago, where they gave me an award for my work in regenerative medicine. And we had this competition between exosomes and secretomes. So I like secretomes as well, don't get me wrong. So the word secretomes goes back to 2004. And as I said, it's a variety of different skin molecules. And they all come from PRP, normally. We make our own exosomes in Dublin. You see T Labs outside. They make their own autologous exosomes, and secretomes come from there as well. So they're produced from platelets, or PRP. I gave my first lecture in IMCAS on PRP in 2001. I used PRP for hair in 2007. The first papers I've seen published were on 2005 maybe, but in hair, probably 2010. So we're very early on doing that. Now, in terms of secretomes versus PRP, you've got to consider that probably all PRP is growth factors. Nothing more, usually growth factors, whereas secretomes is a mixture of everything per se. And we got to understand chemical signaling. I think this is the basis of everything, how cells communicate with each other. And I want you to think of the world outside and cells. Cells model the world outside, and we model cells. To quickly spin through something like this, if you were to take the American Civil War, 1865, they used swords. And we were cutting out cancer, we just cut it out. 1916, First World War. 1914, the Germans used gas, blew back on the British. 1916, they used, Paul Schilling used chemotherapy. Second World War, America dropped the atom bomb on Japan. 2 years later, we had DXRT in medicine killing I suppose, cells. Saddam Hussein, 1983, with ricin, we used it in hematology in terms of bone transplant, graft versus host disease. And then 2003, when they went into Iraq, the soldiers were killed by profiling. In other words, an Iraqi shepherd would walk by a bomb and it wouldn't go off, and an American soldier would get blown up, and we use that in hematology. So I'm just showing you everything that happens in terms of cells happens in the main thing. And I'm mentioning it here in terms of chemical signaling. Now, have any of you watched The House of Guinness yet on Netflix? Nobody? Well, it's the biggest thing on Netflix at the moment. I'm surprised that nobody's watching it. But there's one scene where this Irish guy goes to New York, and suddenly the firemen are after him, but the firemen are just burning down buildings in order to get money. And he runs to this barrier, he knocks on the door, the people let him in, they don't know who he is, he shouts his name, it goes up the block of apartments, and then they know who he is, so they let him into a room. That's the way chemical signaling works. The signal arrives at a cell, it has to get into the cell, so that's like knocking at the door. They're usually adenosine receptors. Then you get this amplification, in other words, the person shouting up, does anybody know who Osman is? That sort of thing. So that's transduction. Then a person says, yes, I know him, and they let him into that room, and that's why that works. Now, in terms of communication, within cells, it's exactly the same thing. We have got different ways within the cell. You can have the brain pituitary affecting the ovary. So, I mean, that's hormonal, that's also signaling it. But the ones we're looking at are usually between cells. So I want you to think for a moment in terms of intracellular communication, secretomes, exosomes. And the cargo, obviously, these exosomes are carrying is all important. If we take American politics at the moment, the big three things that separated the Democrats and the Republicans are what? Communication, what you teach your children, critical race theory, or a lot of left-right differences in terms of what kids should be learning in school. That's communication. Whether roads should be built in America that have spent $7 trillion on wars that have done the country no real benefit, that's defense. So that's immunology. And then in terms of the cell itself, infrastructure repair, that's repair. Defense is obviously whether you fund the army or you don't. So they're the three biggest things in politics, and they're the three biggest things in a cell as well. So if we look at communication, defense, repair, once you start thinking about exosomes or secretomes that way, you begin to understand how they work. I'll take a quick look at exosomes. At this stage, I suppose we all know that they are between 30 and 150 micrometers. I use T-Lab's autosomal exosomes that were outside. They're 600, so I'm sure they're letting through cell debris or maybe even letting through secretomes per se. So exosomes are like a cruise missile going, bang, hitting one place and that's it. So if you're using exosomes for hair, just consider all they're doing is growth factors and follicles. But if you're using secretomes, they're going to work on the scalp, they're going to work on blood vessels, they're going to work on probably 6 different functions, whereas exosomes don't. Exosomes as well are like a person bringing a letter to a postbox, per se. Secretomes are an umbrella outfit that will do all these things. Anti-inflammatory, immune response, chemical signaling. They've got metabolites like amino acids, fatty acids. They contain, obviously, exosomes as well, which contain MRA. Now, what do? They restore function of tissues. That's what I said in terms of repair. Promote healing. Again, back to that. Follicular regeneration in terms of hair. we use them a lot for that. The similarities between them are a little like this. They both are signaling molecules. They both modulate cell behavior. They both have an array of microbiomes, and they both are involved in dysregulation. The mode of reliefs are obviously different, and if you see, the components, to an extent, are sort of similar, and it's not that secretomes don't contain mRNA. MicroRNA is within secretomes, but they're within the exosomes to do it, per se. So some of the benefits, and this just comes from the lecture I had in Cambridge, obviously they contain so many different things compared to exosomes, and they come from mesenchymal cell. I just use this as I made that with AI, showing that exosomes just work on the follicles, but secretomes will work multifunction. In terms of stability, think about it this way. If you're going to make exosomes, in Europe, you're not allowed to use human ones. It's a pity, because I used to prefer human ones. In Europe now, you're not allowed to inject them. You can only get your beautician to roll them in, and it's a pity because injections did work better. Now, I'm not saying that plant ones don't work. Of course they do. But if you think about it for a moment, if you want to make synthetic exosomes, it's very easy making secretomes because it's just a solution of bioactive molecules. But if you are to make exosomes, you have to surround them in that lipophilic structure. And a recent paper from the University of Dallas showed that up to 54% of exosomes don't really work at all, which is a sad thing. They have no FDA approval, and they have very, very little data behind it. Now, what we do like is this technology in the next generation. We know that they have the ability to get into a cell and do things. So what we got to do is obviously change the cargo that's inside the exosomes. So at the moment, all we're doing is using things that are in our cells, hoping that they'll work better, and they'll work in scars, they'll work on hair. But what we need in the next generation is longevity. Putting things in that'll protect our pancreas, protect our heart. So the next generation of young doctors in aesthetic medicine, it'll be mental wellness, longevity, and aesthetic medicine. They'll all blend together into the one thing. Now, the potential benefits of secretomes over exosomes, they're safer and they have less immune problems. I don't think that exosomes are not safe, but they're just taken into account there. Stability per se. So this was made up from my Cambridge lecture. So obviously, if you're dealing with something that needs widespread repair, in other words, Alzheimer's, Parkinson's, brain inflammation that's sort of kicking off, then secretomes are better because they're sort of doing everything. I'm not keeping an eye on my time. How am I doing? I'm okay? Keep going? Right. In terms of the difference between secretomes and exosomes, exosomes excel in precision. They're better at doing one thing, but secretomes are better across the thing. Now, we use them for hair. I used to have 20 hair transplant clinics, and we switched over after the Irish recession. And I'll just show you, the ones we use come from bovine colostrum. Somebody was asking me about these last night. This isn't necessarily promoting this, but these are the sort of results that you get from secretomes and hair. And this is with skin. Now, one interesting thing I want to show you, the way things are changing, is you can get secretomes from hair follicles. So you don't have to do a biopsy. You can take a person in and just pluck some hair follicles, doesn't leave any scarring. Anybody can do it, and you can send this off then. And secretomes, actually, your own personal ones, can be made from these hair follicles. So this is a whole new era. Canadian company has sort of started with this, and you can preserve your secretomes for years. Now, as yet, what they're doing is they're using these topically. I've used, I suppose, in terms of vascular occlusions and burn tissue, certainly with calcium stem cells, which also have exosomes, for many years in red light. And it will make this product. What I didn't realize at the time was stem cells, when we use them, don't work very well. No matter what they say, we thought one generation ago that the work done in Tel Aviv with spinal cord injuries, that stem cells would cure that. With hearts, they didn't. The potential is there, and what is wrong is they're like kids in a bad estate or in a bad housing complex, just breaking into houses, spraying graffiti. Stem cells are doing that at the minute, but they have the potential to be turned. And at the time I used red light, and I didn't realize that it was a vector for making stem cells work properly. And now we're going to use exosomes, because exosomes can tell cells what to do. So if we use them with stem cells, and we have a whole thing starting in Oxford soon at this here. I also will use them in terms of cellular aging, and in terms of the this is a whole other world that we'll start using them in now. Cellular aging itself, obviously with senescent cells, but I'm up to 20 minutes, am I? I think aging is the next generation of things, yeah. You probably know, in terms of senescent cells, senescence itself is a double-edged sword. It's a biological process where we have apoptosis within the cells and they die. It comes as a consequence of telomeres when they're dividing, clipping off the ends. And we know that if we can control telomere shortening, that we'll live longer and the cells will live longer. But the problem is that within the cell, that is done to prevent cancer spreading. Because if we've got a malfunctional DNA or telomere, what will happen will be, if we elongate it, we'll transfer the cancer. So it is certainly critical for preventing damaged cells from dividing, but it contributes to age-related disease as well. So this is a whole big new world as well in terms of inflammation, chronic inflammation, and how we reduce chronic inflammation. And it's an interesting thing. Believe it or not, I have to give a lecture in Prague next week, and it's to do with inflammation of the brain and how we reduce it. We know things like BTL exomind can sort of give you neuroplasticity, but believe it or not, red light to infrared, just from all things like Dermalux, Luma, any of those, they will go into your brain and reduce inflammation, which is interesting. Violet light's the best, but obviously it can't cross the skull. So photobiomodulation is going to be a whole new thing in terms of reducing inflammation on the brain. If you can protect the brain, you'll protect yourself. It's one of the big problems in life that people are living longer, but they've Alzheimer's and they've got brains that aren't working. And one of the things also you can reduce inflammation with is grounding. I don't know whether you're aware of that, where you can attach something. And we noticed that autoimmune diseases and inflammation all started around the 1950s. Has anybody ever thought of that for a moment? Why did it happen then? One of the reasons is that leather shoes changed to rubber shoes and sneakers in that period. And as a consequence, we're not in contact with the earth anymore in terms of our inflammatory process. And it is reckoned that you should take off your shoes walk on your socks or whatever for at least 20 minutes a day, and you'll dramatically reduce your inflammatory markers and cytokines. It's only a simple thing. I could talk all day, I better keep quiet. So we'll see you later for my talk on blindness. Thank you very much.
Thank you for very interesting, amazing, beautiful presentation. Do you have any question or comment?
I'll get out of here before there's questions. I know. Anybody, any questions?
Thank you.